Hi everyone. Here in this video we're going to talk about solving algebraic equations. First we're going to do a little review of what we already know, then we'll learn a little bit about how to solve these equations. What do we already know? We know that a variable is an unknown. So far we have not tried to figure out what that variable or what that unknown is. Now we are going to start figuring out how to solve for the unknown or the variable. Examples include x, y, z, n, m, smiley face, heart. Whatever symbol you want to use can be placed in an equation as a variable. We know an algebraic expression is just two terms or more, but that doesn't have an equal sign. We know an algebraic, some examples are x plus 2, 10 minus y, 5x, written in all these three different ways, or z divided by 10. We also have talked about the equal sign. The equal sign is there to show that an equation needs to be balanced. The equal sign is like the center of the teeter-totter, like right here. So each side has to be balanced. This is what I want you to keep in mind when we're solving our equations. We need to keep them balanced so each side is the same as the other. Something new. Make sure you're filling in your notes as I'm talking and as you're reading. Inverse operations are operations that undo each other. Inverse operations are opposite operations. So addition and subtraction are inverse operations, and multiplication and division are inverse operations. Here are some basic things that you need to know before we start actually solving equations. Your goal when you're solving equations is to get the variable or the unknown all by itself on one side of the equal sign. You want that x or that y or that z on one side of the equation and everything else on the other side. To eliminate a number on one side of the equation to try to get that variable by itself, you have to do the inverse or opposite operation. I'll show you in some examples coming up. Once you do that to one side of the equation, you have to do it to the other side. Kind of like adding and subtracting fractions and making them have common denominators. We have to, whatever you did to the denominator, you had to do to the numerator. Same thing here. Whatever you do to the left side of the equation, you have to do to the right side of the equation. Then you're going to check your answer. Here I'm going to show you some examples. I want you to fill these in your notes, and then tomorrow in class we'll do some more examples and I'll answer any questions you have. So here we go. Y plus 3 equals 8. In order to get this y all by itself, I have to do the inverse operation to get rid of the 3. I have to then subtract 3. What do I get when I subtract 3 from positive 3? I get 0 or nothing. But I also then have to do the same thing to the other side of the equal sign. So I subtract 3. Sorry. So then on the left side of the equation, all I have left is y. And on the right side of the equation, I have 8 minus 3, which is 5. Therefore, y equals 5. That's what we've solved y as. Let's check our answer. We have to fill in our answer with the variable. So 5 plus 3 equals 8, which makes the equation true. Sorry, my handwriting's so messy. I haven't done this in a while. Here we have a subtraction problem. We have 4 minus m equals 12. We want to get this m all by itself on the left side of the equation. First of all, to get rid of the 4, if there's no sign in front of it, just assume it's positive. So we have to subtract 4. So those cancel out, right? So we get rid of that. We have to subtract 4 here. 12 minus 4 is 8. But we have a negative m here. That's not right. We don't want that negative in front. So we'll just make it a positive. But in order to make it a positive, we then have to make the 8 a negative. Let's check it out. 4 minus a negative 8 equals 12. These two negatives become a positive. So 4 plus 8, does that equal 12? There we go. Our answer checks out. Last, I don't want to go too far into multiplication because we're going to do multiplication and division later in the week together. But you see 2x minus 64. To get the x by itself, we have to do the inverse operation of multiplication, so that's division. I divide by 2. I divide by 2. So the 2's cancel out, and I'm left with x on this side. And 64 divided by 2 is 32. But let's check. Let's fill in the x with 32. 2 times 32 equals 64. Is that true? 2 times 32 is 64, so we check out. Division equations to be continued. Like I said, we will do that later in the week or next week because I want to do multiplication and division at the same time. Make sure your notes are filled in. If you have to rewind to go over this, do so that all of your notes are filled in.